Hello, today we're going to be solving composite functions, which is a chapter that shows up on the AP Pre-Calculus exam. And we have around 14 questions. I do suggest you pause the video before watching the solution, try and solve it on your own. And yeah, starting off with question number 1. The functions f and g are given by f of x, which equals to x squared plus 1. G of x equals to 4x minus 1, which of the following is an expression for f of g of x. Now, we're simply just plugging in g of x into f of x. I know that f of x equals to x squared plus 1, so let's say we want to search for f of 2. Well, f of 2 is simply just 2 squared plus 1, which equals to 4 plus 1, which equals to 5. In this case, we're not searching for f of 2. Instead, we're searching for f of g of x. So instead of plugging 2 into x, what I'm going to plug in is g of x, which is 4x minus 1, into x. So now I have 4x minus 1 squared plus 1. Now, you can simply expand this. We have 4x minus 1 multiplied by 4x minus 1. But if you know the FOIL formula, it's very simple. A squared, let me write it down really quick. A plus b squared is simply a squared plus 2ab plus b squared. Now, you can distribute. So 4x by 4x is just 4x squared minus 4x plus 1, plus 1. The answer is simply 4x, I messed up here. 16x squared, so 16x squared minus 8x plus 2. And that would be option C. So f of g of x, you're just plugging in g of x for x into f of x. Okay, question number 2. Two functions f and g are composed such that f of g of x equals to 4 square root x minus 3 plus 2. Which of the following could be the expressions for f of x and g of x? So in this case, we just need to test every single option and see which option would give us f of g of x equals to 4 square root x minus 3 plus 2. Let's test option A. We have f of x, which equals to square root of x, and g of x is 4x minus 3. So f of g of x is simply plugging this into x. We're going to get square root of 4x minus 3, which is not the case. So option A is not true. Moving on to option B. Remember, we're searching for an option that gives us 4 square root x minus 3 plus 2. Looking at option B, f of g of x is simply, we're plugging in square root of x into x. We have 4 square root of x minus 3, which is not the case as well. What about option C? F of g of x is, we're plugging in 4x plus 2 into x. We have square root of 4x plus 2 minus 3, which is square root of 4x minus 1, which is also not the case. What about D? F of g of x, we're plugging square root x minus 3 into x. We have, oopsie daisy, f of g of x, which equals to 4 square root x minus 3 plus 2, which is in fact exactly what we're asked to search for, which is 4 square root x minus 3 plus 2, which is the correct answer. Now, moving on to question number 3. The functions f and g are given by f of x equals 1 over x, g of x equals square root of x. What's the domain of the function h given by h of x, which equals to f of g of x? Now, in this case, f of g of x is simply plugging in square root of x into x. So it's 1 divided by square root of x. Now what's the domain in this case? Always remember with the domain, what's in the denominator must not be equal to 0. And well, since we have a square root, this also means that it has to be positive. So it can't be equal to 0 and it has to be positive, so that basically means x is greater than 0. It's not greater than or equal to 0, it's simply greater than 0. So looking at the answer choices, all real numbers is not true. All real numbers not equal to 0 is also not true. Because what if I have a negative, so let's say 1 over square root negative 4, that doesn't work. And all real numbers greater than 0, well, this is in fact the correct answer. All real numbers greater than or equal to 0, this cannot be true. Why? Because let's say it equals to 0, then I would get 1 over square root of 0, which is 1 over 0, which does not work. So D is not true as well. The answer has to be option C. Okay, question number 4. The piecewise linear function f defined on x is between -4 and 4 is shown in the graph. The function g is given by g of x, which equals to x plus 3. Which of the following is the graph of y equals to f of g of x? Now we're plugging in g of x into f of x, so this is f of x. Now, plugging in g of x, we must first understand what g of x equals to. G of x equals to x plus 3. Now, what happens if we add a number to the x value? How would the function shift? Well, let's say we have y equals to x. This is y equal to x. Y could be equal, so let's just give some random numbers. Let's say 1, 1, 2, 2, 3, and 3. So adding 3 to x, we're gonna, continue on 4, 4, and 5, 5. So adding 3 to x, we're now gonna end up with y, which equals to x plus 3. We're substituting x plus 3 into x. Now, graphing this, I do know that it has a y-intercept of 3 and an x-intercept of -3. Correct? When y equals to 0, x equals to -3. And when x equals to 0, y equals to 3. So it's passing the y-axis at 0, 3, and the x-axis at -3, 0. If you plug in these values, so -3 for x, let me just highlight that, -3 for x, you're going to get y equals 0, and 3 for y, you're going to get, 0 for x and y for 3, you're going to get 3 equal to 3, which does work. Okay, so just drawing this line that's crossing these 2 points, you can tell that this red line, when we added 3, shifted to the left 3 units. So remember, y equal to x was at the origin. Now y equal to x plus 3 is in fact 3 units to the left of the origin, which means that if we add to the value of x, that means the function will shift to how many units you add to that x value. But if you subtract from the x value, it's going to basically move to the right. In this case, we're adding 3 units. So let's say, let's take this point. This is 1, -1, right? Now, it's going to shift 1, 2, 3. So now we're going to have -2, -1. We're going to have to search for this point, -2, -1. Well, this is -2, -1. Yeah, that's pretty much it. This shifted upwards, which is not the case. This shifted to the right, which is also not the case. And with this one, we're missing a part for some reason. We're missing this part. It does have -2, -1, but it's missing a few values. So the correct answer would be option A, because why would this be missing? And this part as well. So it's not option B. Okay, moving on to question number 5, which is a really interesting question. The function p not shown is a polynomial function of degree 3. So p of x could be any polynomial function of degree 3. It could be x cubed plus x squared plus x plus 1. Or it could just be p of x equal to x cubed. It doesn't really matter. The graphs of 4 functions f, g, h, and k are given. So the graph of f is clearly y equal to x. So 1, 1, 2, 2, 3, 3, and so on. The graph of y equals to negative x. Okay, I'm sorry about that. Graph of h, y equals to 1, and graph of k, y equals to 0. Okay, now the output values of p are the same as the output values of the composition function when p is composed with one of these functions as the input function. For which of the functions is this statement true? Which basically means that if p is an input function, so this is f of x, let's say f of x equals to x. This is the first one, right? G of x equals to negative x, h of x equals to 1, and k of x equals to 0. So plugging in p of x, so let's say the first one, if I plug in f of p of x, this should be equal to p of x. If I plug in p of x into g of x, this should also be equal to p of x. Now your question might be, why is that the case? Because let's read this one more time. They're mentioning that the output values of p, what's the output values of p? So this is p of x, the output value is x cubed, right? Are the same as the output values of p are the same as the output values of the composition function. So this is called a composition function, right? It's a function within a function. When p is composed with one of these functions as the input. So p would be the input, and even if it's the input, the output will still be just equal to p of x. So p of x equals to p of x. Now, this is only true. Well, let's test out every single option. So let's test out h. If I plug in p of x into x, what am I going to get? H of p of x is simply equal to 1, because where am I plugging in p of x into? So p of x, remember, we placed it as x cubed. What about k p of x? Well, it's still going to be equal to 0, and 0 is not equal to x cubed, right? And 1 is not equal to x cubed, so this is not true as well. What about g of x? Well, plugging in p of x, I'm simply going to get negative p of x, right? So negative of x cubed, which is negative x cubed. I mean, this is close, but it's not the answer. But what about f of x? F of p of x, this is simply equal to plugging in x cubed into x, right? So instead of writing x, we're just writing x cubed, which is in fact equal to p of x, which means the correct answer is option A. This one is a bit confusing. I do suggest you go over it. You try and do it yourself first. Again, one more time. Like, choose a different p of x and see if that works with f of x. And yeah, that's pretty much it. Moving on to question number 6. We have x, which is negative 1. F of negative 1 would be equal to 0. When x is 0, f of 0 equals to 1. When x is 1, f of negative 1 equals... when x is 1, f of 1 equals to negative 1. The table gives values of the function f for selected values of x. The function g is given by the following, where g of x equals to x squared. Which of the following gives values of g of x for x equal to negative 1, x equal to 0, and x equal to 1? Well, we need to find the table that represents the composition function g of f of x. Now, when x equals to negative 1, well, let's type that in. g of f of negative 1. What's the answer? Well, what's f of negative 1? Isn't that equal to 0? So this is simply g of 0. Now, what is g of 0 equal to? Well, g of x equals to x squared, so it's simply 0 squared, which equals to 0. So when x equals to negative 1, we're going to have to get 0. And that's not true for A. That's true for B. It's true for C, but it's not true for D. Negative 1, 0, negative 1, 0. Okay, let's test the second point, and that will determine which is the correct answer. We have g of f of 0. Now, when x equals to 0, f of 0 equals to 1, so this is simply just g of 1. Now, what is g of 1 equal to? Well, it's just 1 squared, which is equal to 1. Looking back at g of x, which equals to x squared. So the correct answer in this case would be option C and not B. That's it. Okay, moving on to question number 7. The graphs of y equal to f of x and y equal to g of x are given. What is the value of f of g of 1? F of g of 1, I'm sorry. Well, let's first find g of 1. When x equals to 1, g of 1 equals to 2. So now I have f of 2. Now, what is f of 2 when x equals to 2? We have 3, so I have f of 3. Now, when x equals to 3, we have 4, so the answer is simply 4, which is option D. Okay, the graph of the function f is given. If g is the function given by g of x, which equals to 2 times x, so the following is the graph of the composite function y equals to f of g of x. Now, this is f of x. Let's write down some values. We have when x equals to 1, y equals to 2. When x equals to 2, y equals to negative 1, right? Okay. When x equals to 3, y equals to negative 1 as well. And when x equals to 4, y equals to 0. Now, yeah, so they're simply telling us we're plugging in 2 of x into f. So now I have f of 2 of x. So, yeah, we're just simply going to test out the points. Starting off with the first point, when x is equal to 1, when x equals to 1, I now have f of 2, right? And what is f of 2 equal to? Well, I know that f of 2 equals to negative 1, right? So when x equals to 1, just plugging in x equal to 1, I'm now getting f of 2, which equals to negative 1. So let's repeat that one more time, just in case you don't get lost. F of g of x, it is simply f of 2 of x. We're trying to find some new values in order to tell which is the correct answer. And let's just plug in the easiest number where x equals to 1. I'm going to get f of 2 times 1, which is simply just f of 2. Now, what is f of 2 equal to? Looking at the numbers, I know that f of 2 equals to negative 1, right? So when x equals to 1, f of 2 equals to negative 1. So this is the first point, 1, negative 1. Let's plug in another point. Let's plug in 2. When x equals to 2, so this is f of 2 of x. When x equals to 2, I'm simply going to get f of 2 times 2, which is simply f of 4. Now, what is f of 4 equal to? Well, it's just equal to 0. So when x equals to 2, I'm going to get 0. Now, we're going to search for these 2 points. 1, negative 1. Okay, here it is. So this is 1, negative 1. Well, with C, we have 1, 4, which is not true. With this one, we have 1, 1, which is also not true. And with this one, we have 1, 1, which is also not true. So the correct answer would be option D. And this also proves it one more time, which is 2, 0. X equals to 2, y equals to 0. So both points are actually can actually be found with option D. Okay, moving on. The next one, we have question number 9. A drop of water hits the surface of a lake and forms concentric circular ripples. The radius in inches of the circle enclosed by the water ripple increases as a function of time t in minutes and is modeled by the function r given by r of t, which is the following. Which of the following gives the area of the circle enclosed by the outer ripple in square inches as a function of time t in minutes? Note the area of a circle with radius x is given by the following. So we're searching for, we have the radius. This is the radius, right? Yes, it is. And we know that the area equals to pi r squared. So what they're asking us is to find the area in function of time. So instead of writing r or x, we're just going to have to substitute the radius for r. Now I have a, which equals to pi multiplied by 25 multiplied by radius 2t plus 1 squared. So this is pi, and you can distribute this. This is totally fine because 25 is not added to the square root. So I have 25 squared multiplied by 2t plus 1. Okay, and now you can distribute this if you want. So you're simply going to end with pi as well. So 25 squared is 625, and 625 multiplied by 2 is simply 1250. So we have 625 pi multiplied by 2t plus 1, which after distributing is simply 1250 pi t plus 625 pi, which is correct. Okay, moving on to question number 10. We have the function f, which is given by f of x, which equals to e to the square root of 2x. And the function g is given by the following, which of the following is an expression of, for f of g of x. Well, f of g of x is simply just plugging in g of x into x. So this is simply e to the power of 2 multiplied by ln 3x. Now, how do we deal with this? When you have a number in front of the ln, you just simply not distribute it. You take this number and you raise it to the power of the basis of what's inside the parentheses. So now I have ln, this is still the exponent. So ln 3 squared x squared. You see what I did with the 2? You just simply place it as an exponent to what's inside the parentheses. Now, the exponential and the ln function cancel out. You're left with 3 squared, which is 9, times x squared, which is just option A. That's it. Okay, we still have a few questions left. Question number 11. F of g of x, we're plugging in g of x into x. We have f of g of x, which equals to x minus 3, parentheses over x squared plus 1. Now, with the numerator, we have x squared minus 6x plus 9 over x plus 1, which is x squared minus 6x plus 9 plus x over x divided by x. Now, my bad. This is x squared, but we don't really need to work on it, just by looking at the answer choices. This is the correct answer. Don't really need to x squared minus 6x plus 9 over x squared. So let's say we do add x squared. So x squared, this is going to be 2x squared, and that's not the case with any of the questions. Okay, so that's it for C. let's have a look at, that's it for question number 11. Let's have a look at question number 12. The table gives values of the function g for selected values of x. The function f is given by the following. What is the value of f of g of 3? Well, g of 3 is simply when x equals to 3, we get negative 2, right? So f of negative 2 equals to, let's have a look at f of x, which is 3 negative 2, plus negative 2 squared, which is 1 over 9, plus 4, which just by looking at the answer choices is option B. Because 4 by 9 is 36, plus 1, which is 37. Okay. Question number 13. The function c models temperature in degrees Celsius as a function of time t in hours. The function p models electricity usage in kilowatts as a function of temperature in degrees Celsius. Let k be the composition function defined by the following. So it's p of c of t. Now, well, what does p represent? P is simply electricity usage, right? Did I pronounce that correctly? Usage. Electricity usage. Okay. And we have C, which models temperature. So in this case, what does K represent? It represents electricity usage, right? P, as a function of temperature. So it models electricity usage as a function of temperature, which is just option D. It wouldn't be A because it's not as a function of time, function of temperature. And this is the other way around. So it's not C of P of T, right? It's P of C of T. So it models electricity usage as a function of temperature. And yeah, that's it. Let's move on to number 14. We have the table gives values for the functions f and g at selected values of x. Functions f and g are defined for all real numbers. Let h be the function defined by the following. What is h of 0? Well, h of 0 is when x equals to 0. What is g of 0? Well, g of 0 equals to 1, right? And what is f of 0? Well, f of 1 equals to this number, which I'm assuming is negative 2, so that's the answer. Because we're searching for h of 0, which is f of g of 0, and g of 0 is just when x equals to 0. What's the output value for g of x? G of 0 is equal to 1, and f of 1 is equal to negative 2, which is option A. And yeah, that's pretty much it. I do suggest you solve these questions on your own before, well, the video is over, but yeah, just for next time, make sure you solve the questions on your own before watching the video. And yeah, thank you.